Hello, everyone. In this lesson, we will learn how to set tool coordinates using the three-point method and how to activate and verify them. After understanding the purpose and significance of setting robot tool coordinates, we know that by establishing the tool coordinate system in advance, we can determine the tool center point, TCP, during the workpiece grasping process, making it easier to adjust the tool's posture. Determining the tool's feed direction can facilitate adjusting the tool's position. Next, we will learn how to teach a FANUC industrial robot to establish a tool coordinate system through the following content. Through this lesson, I hope everyone can master the steps to set the tool coordinates of FANUC industrial robots using the three-point method, and correctly activate and verify the set tool coordinate system. Let's start with the first part, the method to set the tool coordinate system. So how do we establish a tool coordinate system? This lesson's content, setting tool coordinates with the three-point method, will solve this problem. The tool coordinate system needs to be set before programming. If the tool coordinate system is not defined, the default tool coordinate system will be used. Users can set up to 10 tool coordinate systems. Generally, one tool corresponds to one tool coordinate system. The methods for setting the tool coordinate system include 1. 3-point method, 2. 6-point method, further divided into 6-point method, XZ, direction, and 6-point method, XY, direction. 3. Direct input method. 4. 2-point plus Z method. 5. 4-point method. Next, we will explain how to set the tool coordinates using the three-point method. Follow these steps. First, press Menu, Setup, Frames to enter the Coordinate System Settings interface. After entering the Coordinate System Settings interface, press F3, Other, select Tool Frame to enter the Tool Coordinate System Settings interface. Move the cursor to the tool coordinate system number to be set and press F2, Detail, to enter the detailed interface. In the detailed interface of the tool coordinate system, press F2, Method. Move the cursor, select the setting method, 3-point, and press Enter to confirm. In the 3-point method tool coordinate system setting interface, we need to teach the robot 3 points. When the approach point is not taught, uninitialized is displayed after each approach point. If the robot has been taught the points, used is displayed. Each approach point has 3 steps. 1. Adjust posture. 2. Point to point. 3. Record. The method for recording approach point 1 is 1. Move the cursor to approach point 1. 2. Switch the teaching coordinate to world coordinate, world, and move the robot so that the tool tip touches the reference point. 3. Press Shift plus F5, Record, to record. Recording approach point 2. 1. Move the robot about 50 mm in the plus Z direction of the world coordinate, world. 2. Move the cursor to approach point 2. 3. Switch the teaching coordinate to joint coordinate, joint. Rotate the J6 axis, flange face, at least 90 degrees, but not more than 180 degrees. 4. Switch the teaching coordinate to world coordinate, world, and move the robot so that the tool tip touches the reference point. 5. Press Shift plus F5, Record, to record. 6. Move the robot about 50 mm in the plus Z direction of the world coordinate, world. Recording approach point 3. 1. Move the cursor to approach point 3. 2. Switch the teaching coordinate to joint coordinate, joint. Rotate the J4 and J5 axes, not more than 90 degrees. 3. Switch the teaching coordinate to world coordinate, world, and move the robot so that the tool tip touches the reference point. 4. Press Shift plus F5, record, to record. 5. Move the robot about 50 millimeters in the plus Z direction of the world coordinate, world. When the 3 points are recorded, a new tool coordinate system is automatically calculated. The data in X, Y, Z represents the offset of the currently set TCP point relative to the center of the JE6 axis flange. The values of W, P, R are 0. The 3-point method only translates the entire tool coordinate system without changing its direction. After setting the tool coordinate system, can we use the tool coordinate system immediately? How can we know if the tool coordinate system we set meets our needs? Next, we will explain how to activate the tool coordinate system and verify the tool center point, TCP, position. There are 2 methods to activate the tool coordinate system. First method. If we set the tool coordinates using the 3-point method, directly press Pref to return to the tool coordinate system settings interface. Or return to the tool coordinate system settings interface through menu Setup Frame. Press F5, set end, the screen will display. Enter frame number. Use the numeric keys to enter the tool coordinate system number to be activated and press Enter to confirm. The screen will display the activated tool coordinate system number, i.e., the currently valid tool coordinate system number. You can also press Shift plus Q to display the tool coordinate system number. Second method. Press Shift plus Q, a yellow dialog box pops up. Move the cursor to the tool line and use the numeric keys to enter the tool coordinate system number to be activated. At this point, the tool coordinate system activation is complete. The method to verify the tool coordinate system is: first, verify the X, Y, Z directions. 1. Switch the robot's teaching coordinate system to the tool coordinate system through the coord key. 2. Teach the robot to move along the X, Y, Z directions and check if the direction settings of the tool coordinate system meet the requirements. Then, verify the TCP position. 1. Switch the robot's teaching coordinate system to the world coordinate system through the coord key. 2. Move the robot to align with the reference point and teach the robot to rotate around the X, Y, Z axis, checking if the TCP position meets the requirements. When verifying the tool coordinate system, if the verification deviation does not meet the requirements based on the robot's application, repeat the setting steps. In this lesson, we learned how to set the tool coordinates of FANUC industrial robots using the 3-point method and activation verification. We clarified the importance of setting the tool coordinate system, mastered the detailed steps of the 3-point method, including entering the setup interface, selecting the 3-point method, and teaching and recording 3 approach points. We also learned how to activate the tool coordinate system and verify the direction and TCP position of the tool coordinate system. Through this lesson, you should be able to master the steps for setting tool coordinates using the 3-point method, laying a solid foundation for subsequent learning. Finally, please think about this course and complete the following exercises to consolidate the knowledge points learned today and further deepen your understanding. This concludes today's lesson. See you in the next time.